Well, happy Friday, guys. This is Mr. Baker with your Algebra 2 lesson for today. Today we're going to be working on something called function operations as we officially start our new unit of math here. Here's a little brain teaser for you. Maybe I'll remember to tell the answer at the end. Let's see if I do. Hopefully you can figure it out on your own. You should have a note sheet that you've gotten from your substitute teacher, and there's also a worksheet you'll need to pick up after you're done here today, and make sure that you've gotten what you need from your teacher in order to be able to finish your project that's due on Monday. So for the scatterplot project. So make sure you've got your note sheet out, and here we go. There's an essential question today as we look at function operations. And that essential question is, how do I perform operations with functions? So kind of self-defining. Let's see. Before we get going, my class usually expects me now to tell jokes. So let's see. I've got one about construction, but I'm still working on it. I do have another one about paper, but it's terrible. All right. Okay. I do have a joke about the ceiling. It's probably over your head. Hopefully your eyes are all rolling with those. So let's get on to the math. So little definitions here. So we've got let f and g be two functions. And so we're going to be looking at function notation. So something you should have some memory from Algebra 1, but remember function notation, something like f of x is just going to be taking the place of y for us. So, instead of saying y equals, 3x plus 2, we would say f of x equals 3x plus 2, or g of x equals 4x minus 1. So the function notation itself is just taking place of the y part of the equation. So whenever we plug a certain value of x into the function, it's going to plug it into this x value, or the x variable and this x variable, and then do the math there, and they'd say, f of x equals, or f of 5 equals, if we decided to plug 5 into this particular function, so like f of 5 equals 3 times 5 plus 2. So what value do I get out of the function when I plug 5 in? So 3 times 5 is 15, and plus 2 would be 17. So you'd say f of 5 is 17. So when we plug 5 in, we get 17 out. So why I like function notation is because we can see the x variable value we plugged in and the y value we got out all in one. So I say, when I plugged 5 into f, I got 17 as my answer. And so f and g and h and whatever letter we put here is just a name. It doesn't do anything. It's not like f times x. That's not what that means. Just a way of saying, hey, let's look at function f, and we know we're looking at this one here. And let's look at function g, and we know we're looking at that one. So it's just a name. So we've got two functions, f and g, and they have overlapping domains. For all x values common to both domains, so for any x's that are in both f and g, we're going to look at the sum, the difference, and the product of f and g. We are not going to talk about the quotient or division with function operations right now. It's quite a bit more complex, so we want to start off with these easier ideas of adding and subtracting and multiplying functions. So f plus g of x is going to be equal to, let me fix this up here real quick, sorry. F plus g of x, so that's how you read that. F plus g of x would just be equal to f of x plus g of x. So it basically just means you're going to add the two functions together. The difference property, or how we would define difference as a function operation, would just be f minus g of x, would just be the same as f of x minus g of x. And then the product, so what is f times g of x? So you got to be kind of careful about how you read that when it just says fg like this. Remember when you put two variables next to each other, or two things next to each other like that, we want to multiply those things. And so it can be a little confusing to see it like this one. It just says fg. Really what that's implying is that the f and the g are multiplying each other. So that would just be equal to f of x times g of x. And this may all seem kind of abstract right now, like what am I talking about? Once we start doing it, it'll really make a lot more sense. But, so let's look at a couple examples real quick. All right. So what I want you to notice here is that we have a bunch of different functions. There's f, there's g, there's h, a, b, c. So if I say, let's look at a or h, like we just know that I'm looking at this function, I'm looking at this function, and the letters there are just names. So what's saying here is it wants us to do on number one is take g plus h of x. So I'm just going to take my function g. So I'm going to go up in here and look at g, and then I'm going to look at h. So the idea here was that g plus h of x is the same thing as g of x plus h of x. So well, my g was 3, and then plus h, which is 2x minus 9. And since this is kind of a complex one, I really should put parentheses around it, like all of this is h. And it's even not a bad idea since I'm replacing g with a 3, that or g of x with 3, I should kind of put it in parentheses too. It's one of those ideas like best practices, like this is a way to help you do things more correct, is by putting parentheses with those things as you bring them down. And then, well, what do we need to do here? So as we look outside of those parentheses, like is there any distribution to do? Don't get confused and think that you need to distribute the 3 into here. These things are adding. Distribution is a multiplying idea. There's nothing right here in front of the parentheses except for a 1. And the same thing with the green parentheses here. There's nothing there except for 1. So the parentheses mathematically are not doing anything. So if it makes you feel more comfortable, we could just get rid of them. So it's a good idea to have them there. Because sometimes they are doing something, and so in this case they just happen not to be, so we don't need them, so let's get rid of them. Then we have some like terms to combine, so 3 minus 9 would be minus 6, negative 6, so 2x minus 6. I can't do any other simplifying. We're not solving this or anything like that, we're just basically simplifying these. So g of h of x is going to be equal to 2x minus 6, and we will expect you guys to be rewriting the notation as part of your answer. So this is the way we want your answers to look, as we think about quizzing or testing or anything like that. So do write your answer out fully. So the next one would be c plus a. So I would look at what c is. So here's my c function, and then here's my a function. So what does c plus a mean? Well, that means I'm just going to take c of x, and then I'm going to add it to a of x. So I'm just going to replace those. What is c of x? C of x is in parentheses x squared plus 2. Close those parentheses, plus a of x, which is 3x plus 1. So again, what I'd want to look at here is, is there anything in front of the parentheses to distribute or anything like that? And again, on these cases with the addition, there's nothing here. So the parentheses aren't doing anything particularly important in this case. So x squared plus 2 plus 3x plus 1. And then looking for any like terms, we do have a 2 and a 1 that are like. So I would start with my notation, c plus a of x. I want to look for the term with the highest exponent first, so that would be the x squared, so that's going to go first. Then the term with the next highest exponent would be the 3x. And then the 2 and the 1, as we combine those, don't have any exponent, or any variable, I guess I should say. So that 3 would go last. This is what we call standard form. So there's our answer. If I added c and function a, that's what we would get. We're going to do a couple more examples from this same group of functions. So here we have some subtraction. So again, this first one says c minus f of x. Oops. So looking up here what c is and what f is. And so then what does c minus f mean? That means I'm going to take c of x and I'm going to subtract f of x. And c of x being x squared plus 2. And I want to subtract f, which is negative 2. So again, as we think about what are we doing with these parentheses, we look in front of this red set of parentheses, and there's nothing there but a positive 1. So those red parentheses are not doing anything again, so I'm just going to get rid of them. So x squared plus 2. Then as we go to look in front of the blue set, so we have this negative, or this minus sign. So we have minus negative 2. We know that those two things interact and become a plus. And then the 2. So I should have x squared plus 2 plus 2. And then combining like terms and finishing this problem up. So I'd say c minus f of x equals those like terms, those two 2's. So x squared is going to start that off, and then plus 4. So there's c minus f. All right, last one of these. So a minus b. So there's a. Here's b. So what does that mean? It means that we're going to take a of x, and we're going to subtract b of x. So a of x, so parenthesis 3x minus 1 minus b of x, which is 4x minus 5. Okay, so again, looking at parentheses, in front of the green parentheses, there's nothing there but a positive 1. So they are not really doing anything. I'm going to get rid of those. And then in front of the orange parentheses, again, there's that negative, and so you kind of think of that as distributing in here, since there's multiple things inside these parentheses. So you could think about distribution. So that minus sign or the negative sign times the 4x would give us negative 4x. And then the negative times the negative 5 would give me positive 5. So we're seeing that the parentheses here with the subtraction are actually doing something sometimes. So why it was actually important to do that in the first place, just kind of get in that habit. So I've got some like terms here. We've got some x's that need to be combined. I've also got some constants that need to be combined. So I have 3x minus 4x, so that would be negative 1x, or just negative x. And then negative 1 plus 5 would be positive 4. And then I'm just going to put my notation in front of that, so a minus b of x equals negative x plus 4. Again, here we'll be expecting you guys to put the notation on your answers, so just get in that habit. All right, same functions, and now looking at some multiplication ideas. So again, this idea of when we just put these two letters next to each other, we are implying that they are multiplying each other. So this really says that we're going to be taking f, which is just negative 2, and then c, which is x squared plus 2, and we're going to be multiplying those two functions. So this will be the same thing as f of x times c of x. So again, as I bring f of x down, that is just negative 2 times, and so I can just use parentheses next to parentheses. I don't need to put a dot, but if you want to, you can. C of x, which is x squared plus 2. So as I look right in front of the parentheses, if I look right in front of the red parentheses, there's nothing there but a 1, so they aren't going to do anything. But if I look in front of the green parentheses, there's this negative 2. So that negative 2 is actually going to be distributing into the green parentheses. And so of course that would just give me negative 2x squared and then minus 4. And so just putting the notation on there, fc of x would be equal to negative 2x minus 4. So if we took those two functions and multiplied them, we would get that. And then HA of x, let's see what that gives us. So h being 2x minus 9, a being 3x plus 1. So I'm going to be taking h of x and multiplying it by a of x. And kind of same thing as I look at the h, I want to put that in parentheses, so 2x minus 9 times, this time I'm not going to put the dot there, 3x plus 1. So just letting the parentheses sit next to each other, knowing that that means we should multiply these. Hopefully you recognize this as something you may have learned as FOIL. I think we usually call it double distribution, so that we want the 2x to distribute to both the 3x and the 1, and we want that negative 9. So make sure you see that as a negative 9, not just a 9, to distribute to the 3x and also to the 1. So 2x times 3x, so 2 times 3 is 6, and then x times x is x squared. 2x times 1 would be positive 2x. Negative 9 times 3x would be negative 27x's, and negative 9 times 1 would be negative 9. A little bit of like term combining we need to do here in the middle. So the 6x squared is going to come down. 2x's minus 27x's is negative 25x's minus 9. So HA of x equals 6x squared minus 25x minus 9. All right, so there's our multiplication ideas. So hopefully it's nothing too bad, just kind of getting used to the notation. You're adding like terms, you're subtracting, so watching that distribution of that minus sign, that negative sign. Here we sit with the multiplication, some distribution or some double distribution, all things that you've definitely done a lot of in your math careers. So just really getting used to the notation, making sure you're putting the notation on your answers, and then doing those operations, which you guys should be pretty familiar with from going through Algebra 1 and geometry. So I'm going to change things up just a little bit as we head to the next slide about what you're being asked to do, but a lot of it will look familiar. Before we were being asked to just perform a particular operation. Here, what we did back here, so where we just were performing the operation on, and when the x was still in the problem, how our function basically came out as a new function was our answer, versus when we had. So we do have some new functions here. Notice that this time we're being asked to evaluate. So usually what evaluate means, we want to plug in a number, is what I think about when it says evaluate. But we want to end up with some number answer is really what this is, some value answer. So let me say evaluate. So this, just looking at function notation. So here they're saying, what's f of negative 2? And I kind of showed you what that looked like earlier. So I want to be looking at f here. Basically, anywhere I want to take that x, anywhere I see an x, and I'm going to plug a negative 2 in for it. So f of negative 2 equals negative 5, and then I'd say x, but negative 5 times negative 2 plus 7. So I replaced x with negative 2. Then we just need to work on simplifying that right-hand side. Negative 5 times negative 2 being positive 10 plus 7. The left side does not change. This is not, again, it's not f times negative 2 or anything like that. It's f of negative 2, letting us know that we're plugging negative 2 into f. So f of negative 2 equals 17. Again, we do expect you guys to leave your answers in function notation. The idea is if I said, hey, f of negative 2 is 17, you would know that I plugged my x value was negative 2, the answer was 17, and then there was function f that we use. So it tells you all of those things when you write it that way. So we do expect you to be using that notation. So h of 3, that's how you would say that. So we're going to go here to our h function. Again, I'm going to plug a 3 in wherever I see an x. So h of 3 equals, so I got negative 2x squared. Negative 2 times 3 squared minus 3 times 3, and then plus 1. All right, so we should be thinking along the lines of PEMDAS here, parentheses, exponents, multiplication, division, then addition, subtraction. So looking inside those parentheses, there's nothing to do. It's 3 is as simple as I can make it. Then looking on the outside parentheses, we do have an exponent. So a pretty common mistake here is people that think that they need to take the 2 times 3 first and then square it. And that's wrong. You should be squaring the 3 first and then multiplying by 2, or negative 2. So you get negative 2 times 9 minus 3 times 3 plus 1. Now I can start looking for multiplication. So negative 2 times 9 would be negative 18. Negative 3 times 3 would be equal to negative 9, and then plus 1. And now all I have left is subtraction and addition. So negative 18 minus 9 is negative 27 plus 1, and then negative 27 plus 1 is negative 26. So when I plugged 3 into h, I got negative 26 as my answer. So the x value is 3, the y value would be negative 26. We were thinking about like graphing these points or anything like that. This first point would have been negative 2, 17. We could plot that on a graph. This next point would be 3, negative 26 if we were going to plot this on a graph. All right, last one like this. Here we're looking at g of 1/2. So looking up here at g, again, I'm going to replace every x up there with a 1/2. So g of 1/2 equals 4 times 1/2 minus 9. So g of 1/2, of course 4 times 1/2 is 2, minus 9, and then 2 minus 9 is negative 7. So g of 1/2 is negative 7. Again, we do expect you to write your answers in function notation. If you wanted to think about that as a point, that would be 1/2 negative 7. The x value is 1/2, the y value is negative 7. Okay, so there's some simple just evaluating functions. We're going to look at function operations along with that. Okay. So last little bit of this. So here we have some functions. So different, the same functions, but we're going to be using operations and evaluating. There are a couple different ways to do this. What I feel is easiest is to go back to the notation. What does f plus g of x mean? That meant that we would take f of x and g of x, and we're going to add them. Except for this time we're not taking f of x, we're taking f of negative 2. So f of negative 2, and then we're going to add it to g of negative 2. So I'm going to figure out what f of negative 2 is. Move this a little bit. So f of negative 2, so that'd be negative 5 times negative 2 plus 7. So negative 5 times negative 2 is positive 10 plus 7. That would be 17. And then g of negative 2 equals, so 4 times negative 2 plus minus 9. So that would be negative 8 minus 9, which is negative 17. So g of negative 2 is negative 17. And so what we said we were going to do up here was we were going to add them. So I'm going to take 17 and add it to negative 17. And so what that means is that f plus g of negative 2 equals, well, 17 plus negative 17 is 0. So when I figure out what f of 2 is, negative 2 is, and what g of negative 2 is, and then when I add them, turns out the answer is 0. Here we have h minus, h minus f. Let's see. So h of 3. So I'm going to figure out what h of, or I guess let me talk a little bit slower. This is going to be the same thing as h of 3 minus f of 3. I'm going to lay this problem out a little differently. I'm just going to do the h part first. So h of 3. So it'd be negative 2 times 3 squared minus 3 times 3 plus 1. So make sure you replace every x with a 3. So there's no more x's right now. Of course, again, with this same problem here, make sure you square first. That's 3 squared. So negative 2 times 9 minus 3 times 3 plus 1. Negative 2 times 9 was negative 18. Negative 3 times 3 was negative 9 plus 1. Negative 18 minus 9 was negative 27 plus 1 was negative 26. So h of 3 was negative 26. Now below that, instead of next to it, I'm going to do the f part. I'm just going to kind of keep that. I'm going to underline that so I don't lose it. I'm just going to do the f part below it. So f of 3. So go back up to f. That'd be negative 5 times 3 plus 7. Of course, negative 5 times 3 is negative 15 plus 7. Negative 15 plus 7 is negative 8. So f of 3 equals negative 8. And it told me it wanted me to subtract them, right? H minus f. So my h value being the negative 26 minus the f value, which was negative 8. So make sure you have all these minuses and negative signs here. And of course that double negative in the middle is going to be turned to pluses, so negative 26 plus 8. So h minus f of 3, negative 26 plus 8 would be negative 18. So when I figure out what h of 3 is, and then I figure out what f of 3 is, and then I subtract them, I get negative 18 as my answer. So there's the, again, the two answers, the h of 3, and then the f of 3, and then the difference of those two things. All right, the last one of these kind of random problems. We're going to look at a word problem as the very last thing we do. This says fg of 4. So remember what that means. We want to take function f at 4, and we're going to multiply it to g at 4. So again, what I'm going to do is start off by figuring out what f of 4 is. So it's negative 5 times 4 plus 7. Negative 5 times 4 is negative 20. Negative 20 plus 7 is negative 13. So there's my f of 4 value. Again, I'm just going to underline that so I don't lose it. And I want to find out what g of 4 is. g of 4 is 4 times 4 minus 9. So 4 times 4 being 16 minus 9. 16 minus 9 is 7. So g of 4 is 7. Again, underline that. What we were asked to do is multiply those two things. So I'm going to take negative 13, multiply it by 7. So going back into my notation, f g of 4. So negative 13 times 7, so 7 times 10 is 70. 7 times 3 is 21. So 70 plus 21 would be 91. So this is going to be negative 91. All right, so there is evaluating using a function operation. So notice again that our answers here are numbers, not new equations. So again, just compare what we did here to a number in the parentheses taking the place of x, that our answer is just a number. So be careful about what you're seeing, what you're being asked to do. Evaluating, or your answer should end up as a number of value. All right, last problem. So here we got Free State Inc. produces HD videos of events. Each video costs $20 to produce, and the company charges $24 per video, plus a flat fee of $50. I almost said flat feet. So flat fee of $50. So we're going to write a cost function and a revenue function. So this is definitely something that businesses do. They worry about how much they're spending to make things, and then how much they're selling those items for, and the difference between those two numbers is the idea of. I'll explain that here a little bit. So we want to write a cost function. So that's the first thing we're being asked to do. So they're asking us to name that c of x. So instead of f of x or g of x or a of x, it's going to be called c of x, and be capital C there. So being very specific about that. So they want us to give it that particular name. We want to go through the problem and look at anything that's talking about, them spending money. So each video costs them $20, and then the company charges $24 per video plus a flat fee. Those things aren't costs. The only thing that talked about cost was this $20. Okay. So our function c of x equals, so each video, I know I talked to my students about each and every and per all being rate words or slope words, which would tell us that this 20 is our slope. So it's going to be multiplied by our variable, which in this case, our variable is not c, our variable is x. Remember, c is just the name of this function. It's the cost function, but it's a function according to x. So we should be multiplying this 20 times x. There's no other charges mentioned or anything like that, or costs mentioned, so that's all there is to it. There's our cost function. Okay, so we wrote a cost function. Next thing we also want to do is write a revenue function. So revenue, that's money that your company brings in. Okay, so we want to go back and look for anything that's related to them earning money, or what they charge, or money they're bringing in. So we already talked about what their cost was, so we see that the company is charging $24 per video plus a flat fee of $50. So again, there we see that per again. So that's that idea, that's the rate word. So our function's name is r, our variable is x. So that $24 per, that means that's 24 times x, and then a flat fee of $50. So it's a one-time fee. So they would add that on to your charges, so plus $50. So there's our revenue function, and there's our cost function. It says it wants us to subtract them, is the next thing. So I'm going to take r, and I'm going to put that in parentheses. So 24x minus plus 50. Fix that too there. Minus C, which is just 20x. So again, just think about what the parentheses do in this case. The purple parentheses aren't doing anything because there's nothing in front of them, so they're just going to go away. And then the blue parentheses do have a minus sign in front of them, but there's nothing to distribute it to per se. It's just we need to remember that it says minus 20x. And so then we have these like terms to combine. So 24x's minus 20x's is 4x's. And then of course the plus 50 just drops down. So here is r of x minus c of x equals 4x plus 50. They have asked us to do quite a few things separately. So they asked us to write c of x. They asked us to write r of x. They asked us to subtract those two things. And then the last thing they want us to do is explain what the difference means. What does this 4x plus 50 represent? So money that your company brings in minus money that it's spent is profit. So revenue minus costs equals profit. So the money left over from what you've brought in after you've paid off all your expenses is your profit. So this function would represent the profit. That Free State Inc. would make for each event. So let's say they covered the homecoming dance and then they were able to sell something like 200 videos. And so we could say the profit for selling 200 videos would equal 4 times 200 plus 50. And so that'd be 800 plus 50, so that'd be $850. And then say that they go and they cover the state high school football game and championship, right? And so they go and they make videos for that, and they sell 1,000 videos. And so for that event, so 4 times 1,000 plus 50, so 4,000 plus 50, so 4,050. So how much profit did they make at the homecoming? They made $850 profit. How much did they make at the state football game? They made $4,050 profit. So that's kind of the idea behind that. You guys didn't need to write that stuff down. I was just kind of showing you what that would mean, how they would use that. So, all right, that's the end of that lesson. You guys should have a worksheet to do for this. Again, you should be working on your projects. Those are due Monday. This worksheet will be due Monday. Hopefully you have a lovely weekend. And I'm sure if you need anything from your teachers, you can always catch up with them at the end of the day. Take care.